Hello everyone, Jason here. I just want to make a quick video on the chi-square goodness of fit test in SPSS. Now, this is a non-parametric test, and when you're doing this test you'll have generally just one sample and you're comparing that sample to the population. And we're going to have two options for our null hypotheses. One is that our expected frequency distribution is going to have equal proportions for each category, or we will have no difference from a known population. So we have our expected frequency distribution, and then we have our observed frequency distribution, and we're just comparing the two to see if there's a significant difference between them. Visually, if we're expecting equal proportions in each category, categories A, B, C, and D, then clearly we don't have that, but we have to do a test, a statistical test, to be able to say conclusively whether or not this distribution is in fact different from this distribution. So we have our degrees of freedom, that's the number of categories minus 1. So we have 4 categories minus 1 gives us 3. N is the number of people in our sample. So if you add these up, we have 60 people in our sample. And finally, we calculate our chi-square statistic, which is the frequency observed minus by the frequency expected, square that value, divide it by the frequency expected, and then sum that for each of these options. So we'll have 4 of these adding up. And when we solve for this, we're going to get 4.53. You can go ahead and check your work if you want to confirm that value, but how it's going to look is you're going to take the corresponding frequency observed, 20, minus the corresponding frequency expected, divided by the corresponding frequency expected, square that value. You'll get something, say x1, and then if you do that for each category, so this is for A, do that for B, C, and D, add them all up, you'll get 4.53. So we don't need this here. Now, actually, yeah, let's take that. We're going to also have our critical chi-square value, all right, and that's going to be, well, you can find that from the back of your textbook for your chi-square distribution, and you're going to need to know your degrees of freedom. And when you look it up in the textbook, depending on what significance value you want, maybe you want 0.1 or 0.05. In this case, I'm going to use 0.05. Alpha is 0.05. Therefore, I'm going to have a significance or a critical value of 7.81. In this case, 4.53 is not bigger than 7.81, so we will fail to reject the null hypothesis. In other words, we do not have enough statistical information to be able to say that these two samples or populations are different from one another. Now let's do that in SPSS real quick. Here we go. Boom. I have one variable. We have 4 categories, A, B, C, and D. And if I go to my data view, you can see the 1s, the 2s, and the 3s all correspond to the correct number of frequency distribution values. If I just quickly look at this in descriptive statistics, you'll see again, A has 20, B has 12, C has 18, D has 10. That's exactly how we had it right here. 2012, 18, 10. 2012, 18, 10. Perfect. Let's do our chi-square. I'm just going to go directly to non-parametric tests. Here we are. Legacy dialogues, chi-square. Throw in the one variable into the test variable list. And here is where you'll choose your null hypothesis option. All categories equal, or you specify the expected value in each category. All categories equal is the option that we had chosen in the previous example. So I'm just going to hit OK. And here we have our observed N, our expected N, all categories equal. And we have our chi-square value, which is 4.533. And we have our degrees of freedom, which is 3. And our significance is 0.2, so 20% chance that this sample occurs if the null hypothesis is true, which is pretty high, 20% chance. I wouldn't bet too much on a 20% chance. So that's how you do chi-square goodness of fit test in SPSS. You can see we got the same values here. If you have any questions, please feel free to message me. If not, stay tuned for my next video in this video series. Cheers.